All right, I think I agreed along homework assignment yesterday for today, but we'll go through what we're going to talk about here with respect to infinite limits. We'll come back to the tangent lines. You're going to need your calculator today. We're going to still talk about the idea of limits and what is occurring with respect to limits. With the idea of limits. Notes out here for you. Okay, what we are doing is we're taking our limit as x approaches infinity, which means x is just getting bigger and bigger and bigger. These are infinite limits. Talking about infinite limits, and when we talk about infinite limits, your x value is going to get larger towards positive infinity or to negative infinity. It's just going to keep on getting bigger and bigger and bigger and bigger. And what we're going to do is we're going to go back to our basic idea of limits. The fundamental idea of limits, and use our function values in our calculator. We want to type in our function y equals x, or y equals 1 over x. 1 divided by x. And we're going to go to our value, and we want to calculate our values as x gets bigger and bigger. The problem you're going to run into, though, is my domain's not going to allow me to do certain things. So what I may have to do with my x values, because once I get past my 10 up here, I'm going to run into difficulties. So let's go to Window. We could do our x max at 1 million or 10 million. At 10 million, and scale this out every million. So I can calculate values basically at that point. So if I go to second and calculate my values, I don't have a bunch of hashes there. I'm spacing out every million. So I'm going to calculate my values. I'm going to calculate them at 10, 100, 1,000. I'm going to get my x value bigger and bigger and bigger. Or if I want to, I think I could just plug this in also. I just have 1/10. We have 1/100th. We have 1,000th. We have 1/10,000th. We have 100,000. And what we see as x gets larger and larger and larger and larger, what is y getting closer to? 0. We're getting closer to a value of 0.
Can you go back to the window? I didn't get all that set. Can you go back to the window? I didn't get that all set. I said the x minimum.
Go to your x maximum. Go to Window. I put my X maximum at 1 million or 10 million. I have what? 1 and 3, 6, 7 zeros there. And I X scaled this out at 1 million, so I have 1 and 6 zeros there. What this allows me to do is this allows me to put in values of X that are large. If I didn't do that, when I would try to put in 1 million, I would get an error because I was beyond my scale. It doesn't matter what the Y is. But what we see here, as we keep on getting bigger and bigger, we just keep on getting closer to a value of 0. As X gets bigger, 1 over 0 gets smaller and smaller and smaller. Well, what if we had 5 over X? And I want to see what happens when I have 5 over X. Well, I can put in my Y equals, my Y1 equals 5 over X. I can divide by 10, divide by 100, divide by 1,000, divide by 10,000. And find my Y values. As we put in our values of X and solve for Y, what is our Y value getting closer to still? 0. I got 5 tens, 5 hundreds, 5 thousands, 5 10,000s, 500,000. So this is 0.5, this is 0.05, this is 0.005, this is 0.0005. This is 0.000005. So, oh, I'm sorry, I went too many zeros there. But what we can see is our number keeps on getting smaller and smaller and smaller and smaller. So we're still approaching a value of 0 here. So if I have a limit of a constant divided by X, I'm going to get a value of 0 here. But what happens, what if I have 2X over X plus 1? Now what you're going to want to quantify or do in your calculator is quantify your numerator and your denominator. So in your Y1, put your parenthesis, 2X, close your parenthesis out, divided by parenthesis X plus 1, and close your parenthesis out. And plug in your values for X.
Mine's the only graph that says window range is messed up. Because whatever this is a 6 up there, I don't know why.
before we got into there. But you have your Y minimum at 10 and your Y maximum at 1. Go negative 10 to 10 with that. That's letting me work it.
Yeah.
As we get bigger and bigger and bigger, what is our Y value getting closer to?
2.
A value of 2. I have 2 over 20 over 11. I have 200 over 101. We have 2,000 over 1,001. We have 20,000 over 10,001. We have 200,000 over 100,001. So the value that we are getting closer and closer to is a value of 2. Well, let's take 3x over 2x plus 1. So once again, you need to quantify the numerator and you need to quantify the denominator. What value are we getting closer to here, Preston?
1.5.
1.5. We're coming down and we're getting closer and closer and closer to 1.5, which in a fractional form is 3 over 2. Quantify your top, quantify your bottom. Put that into your Y1. are we getting closer to?
Negative 1.25.
Negative 1.25. Which is, if I put this into a fractional form, negative 5/4 in a fractional form. So the question is, rather than going through what we had to go through to find my infinite limits, which is always a possibility. If you're sitting in a college, on a college exam, or you have a college prep exam, or an entrance exam for mathematics, and they want to test you in your mathematics, and you have a limit there, an infinite limit sitting there, and you don't quite remember what to do, you can always go back to your calculator and just start plugging in the values and figure that out. But there is a technique to be able to find this out. The key thing to remember is if you take the limit as x approaches infinity of some constant over a variable x to the nth power. Yeah, it should be an x to the nth power there. And n has to be greater than the value of 0. Okay, n cannot be less than 0 because that would be a negative exponent. And if this was a negative exponent, it would shove it up top. So we can't have that. But if I have some constant over x to the nth power, this will always equal 0. If I have a constant and my number on the bottom just keeps on getting bigger and bigger and bigger and bigger and bigger, this will go to a value of 0. Doesn't matter what the constant is. If it was negative 15, I would still get closer to 0. Well, how do I utilize that idea in our problems? Well, if we take a look at this problem up here, we'll go back to this problem up here. And we're going to use a property of fractions, equivalent fractions. Equivalent fractions are fractions that they don't look the same, but they mean the same thing. If I eat 1/2 of the pizza, and I ate 3/6 of the pizza, I ate the same amount. That is called equivalent fractions. Well, within equivalent fractions, we can multiply entire numerators and denominators by the exact same thing, or divide by the exact same thing, and not change my fraction. I come into an equivalent fraction. The idea of complex fractions. We can multiply through by something. Well, what we're going to do is we're going to choose to multiply through. We're going to multiply or divide through by our largest degreed exponent variable, which is x squared. All we're doing is we're reducing a fraction down. If I had 3/6, I could divide top and bottom by 3 to give me 1/2. Now we reduce fraction. Well, I'm going to divide through by x squared. So what we're left with is the limit as x approaches infinity of 5x squared over x squared plus 4x over x squared minus 3 over x squared. We divided everything through by x squared on top. And then we're going to divide it through by x squared on the bottom. So we have 1 over x squared plus 2x over x squared minus 4x squared over x squared. Divided everything through by x squared. So what we are now left with is the limit as x approaches infinity. Well, if I reduce my fraction down, I have 5 minus or plus 4 over x minus 3 over x squared. Now on the bottom, we're left with 1 over x squared plus 2 over x minus 4. Now the nice thing about limits is limits you can put anywhere. If I'm taking the limit of this entire fraction, that's the limit as x approaches infinity of 5. The limit as x approaches infinity of 4 over x. Limit as x approaches infinity of 3 over x squared. Limit as x approaches infinity. I'm taking the limit of each one of these terms. Well, as x gets bigger and bigger and bigger, what happens to the value of 5? Limit as x approaches infinity of 5. As x gets bigger, do I have a value to put in for, do I have a variable to put our value into? Once again, well, if I put 10 in for x for 5 over there, if I put 100 in for x, I put 1,000 in for x over there, is my value getting bigger and bigger? No. It's staying the same. It's 5. So if I take a look at what we're dealing with here, take the limit as x approaches infinity of 5, I get 5. Limit as x approaches infinity of 4 over x. That's going to give me what? As x gets bigger and bigger, that's going to give me what? Limit as x 0. So we have 5 plus 0. And if I have negative 3 over x squared, as x gets bigger and bigger, what's going to happen? Where's that going to go to? 0. It's just going to get there faster if you want to think of it that way, because I'm squaring my x value. Then on the bottom, I have 1 over x squared. That gives me 0. 2 over x, I get 0. And if I put x in for, increase my x value for just the value of constant of negative 4, I'm going to still get negative 4. So we're left with 5 plus 0 minus 0, which is 5 on top, and negative 4 on the bottom, which gives me my negative 5/4. Take a look at the one down here. We take our largest degreed exponent, or term, variable. I have 7x squared plus 4x minus 3. I have 1 plus 5 over x minus 2 over x squared. My largest degree is x squared. So we're going to divide through by x squared. So we have a limit as x approaches infinity. Now, I'm hoping that you can do some mental math here. Okay, as you've seen one, we can start going through. I take negative or 7x squared divided by x squared. That's just going to give me 7. 4x divided by x squared is going to give me 4 over x. Negative 3 divided by x squared will give us negative 3 over x squared. Then on the bottom, I divide everything through by my x squared. 1 over x squared plus 5 over x minus 2. And hopefully, once again, you can use your mental math here to be able to do that. And you don't have to do that additional step that we did up there. These all go to 0. So we're left with 7 plus 0 minus 0 over 0 plus 0 minus 2. So we have negative 7/2. Go ahead and do the last one here. Well, what do you come up with?
5.
5/4. 5/4. Now what you should be able to do is on page 138, your 15 to 37. Sorry about that. Jumped the gun a little bit.
I saw it yesterday.
Yeah.
This doesn't look.
Yeah. I jumped the gun a little bit. That's okay. I did stuff for the next section, section 2.7. If you want to, here we go. Page 148. You can add that into there, page 148, 5 through 8. 5 through 8, and that's, you're finding the equation of a tangent line. Problems 5 through 8 on page 148. Like I said, I sort of flipped the two around. Questions? Tomorrow we'll come in, we'll work on graphs and what is the ramifications to limits on graphs. Tomorrow we will also be videotaped. So, very good quiz.